I know after today, in the fun activity we did, you're really eager to learn more about continuity. So we're going to talk in this little video lesson about removable and non-removable discontinuity. And I'm going to show you an easy way to remember non-removable and removable using functions that we're familiar with, graphing them, and talking about what's happening at a point of discontinuity. Here's a function, f of x is equal to x squared minus 1 all over x minus 1. Now, first thing you want to notice whenever you see a rational function like this, you've got a restriction on the domain. I can't have 0 in the denominator, so I need to make sure what's really clear to me is, oops, x cannot equal 1. So, let's see what this looks like if I were to graph it. First, I can actually notice right away that that numerator can be factored. X plus 1 x minus 1 all over x minus 1, and this works out really nicely. So I have what we call an equivalent function to the original, but I must adhere to this domain restriction that x cannot equal 1. So what does that look like when I graph it? Well, let's do a quick graph here. X plus 1 is pretty simple to graph, but I'm also thinking about what is happening if I want to find out what f of 1 is. So I can kind of draw a picture of it, actually. So f of 1, I can plug it in here and get 2. Well, what's happening there at 1, 2 is a hole. And I can think of that hole as removable discontinuity. So this is considered removable discontinuity. The neat thing is I actually removed these factors, right? I removed x minus 1 from the numerator and denominator to get a new function in order to graph this. So at x equals 1, I have a hole. We call that removable discontinuity. Think of canceling the factors or removing them gives me the removable discontinuity. So what do you think non-removable discontinuity is? Let's see. I'm going to give you a pretty basic function, f of x, one of those parents that we've talked about, equals 1 over x. Now, it's pretty simple. I can't simplify this anymore, but I do know that I have a domain restriction. X cannot equal 0 in this case. And what does it look like when I graph it? I graph this function, and I get here and here. What's happening at x equals 0? Well, there's a vertical asymptote at x equals 0. And guess what we call this? Non-removable discontinuity. Discontinuity. Oh, I can't spell. Discontinuity. There. Removable. I removed a factor. The graph has a hole. Non-removable. I didn't remove any factors. I didn't rewrite this. I have a vertical asymptote. Non-removable. A little more official way to think of this is I can never figure out what f of 0 is. This does not exist. And because it does not exist, I have non-removable. Back in this example, I could figure out what f of 1 was, where there was an issue. So we call that removable. Sound good? Alright, see you tomorrow.